Hello all. Let's talk about the normal probability distributions and especially the standard normal distribution. The standard normal distribution, as we've covered before, is the normal distribution of the standard variable z, right? Otherwise called as the standard score or z-score, okay? Standard score or the z-score. Okay, so now this standard normal distribution is mostly represented by this bell-shaped curve that we have right over here. And we've talked about before some of the properties of the standard normal distributions, right? But let's mention them again today. The first property is that the total area under this normal curve here, right, the total area is 1. So that is the first property, and that is a very important property. The other property is that this distribution is symmetrical, meaning that it extends indefinitely, right, without touching these the x-axis, and that means that this divides the area into two equal halves. This half here is 0.500 and this other half is 0.500. Okay? Another property is that this standard normal distribution has a mean of 0 and a standard deviation of 1. So the mean here is 0 and the standard deviation is 1. Right? And the last property of a standard normal distribution is that nearly all area here is between minus 3.00 z and a z of 3.00. So nearly all of the area is between z of minus 3 to z of plus 3. Okay. Let's draw now the standard normal distribution according to the empirical rule. So we said that this is mu, right, and that is 0. One thing that we know about the normal distribution is that the normal distribution is divided into two halves, 50% on each side, because the distribution is symmetrical. Okay? So that is one. Second is that 68% of all cases fall between plus minus 1 z, or 1 standard deviation. Okay? So now if we have 68% of the cases, these 68% here will fall between 1.00 z and minus 1.00. Okay? Because that's the standard score z. So if this is 68%, then we have 34% on this side and 34% on this other side. Okay? Now we said that 95% of all cases will fall between two z's. Right? Two z's are right over here. So if it's 95%, right? 95%, middle 95% will include the 68% plus 27 more percent. So this 27 more percent is divided in two since the distribution is equal. So we have 13.5% here and 13.5% here. Right? So 68% plus 27% will equal 95%. right? So this 27% divided by 2 is 13.5% each. So one half is here and the other half is here. Okay? And next is that 99.7% will fall between three z's. So 3z is right here, 3.00 and minus 3.00. So now we have 99.7 minus 95. Okay, we have 4.7%. Divided by 2, we will have 2.35% on this side and 2.35% on this other side. Okay? So in this case, we drew the standard normal distribution in this bell-shaped curve. So remember, almost all area is between minus 3 distribution as z-score and plus 3z. Okay, almost all, and that is 99.7 is almost all. Okay, let's just talk about these concepts here. Percentage, proportion, and probability. These are basically the same concept. A percentage, such as 50%, okay, is usually used when we talk about a proportion of a population. So 50% would be 1/2 of a population, right? So percentage usually is used when talking about a proportion of a population. Now probability, on the other hand, is usually used when we talk about the chance that an item will possess a certain property. Okay, so this would be a probability written in the form of a decimal with 4 decimals, such as 0.5000, which is the same as saying 50% or the same as saying 1/2. Okay, now the area is basically the graphic representation of all of these three concepts when we draw a picture to illustrate the situation. So for example, the area from this z-score to the left will be all this area here, okay, under the normal curve, and that is associated with a percentage, with a proportion, or with a probability. Let us now solve some exercises or problems and find the area associated with a z-score. Let's imagine that we want to find the area under the standard normal curve to the left of z 1.24. Okay. Now for this, let's visualize it first in the normal curve or bell-shaped curve graph here. We know that the mean of a standard z variable is 0, okay, and the standard deviation is 1. So since the z-score is 1.24, then this would probably fall just above the 1z. So this is going to be z equals 1.24. So let's understand that again. So from this point on, right, from this point on, 1.24, right, we want to find the area under the standard normal curve to the left of this. So what is going to be the area to the left? It's going to be all this area here, right? So all of this. So we need to find the area that is under z 1.24. Okay, so how do we find that? We already know that this is 50%, right? So it's going to be more than 50 here. And also, since one standard deviation above the mean is 34%, then we know that this is going to be greater than, okay, greater than 84%. But what is exactly the area? In this case, we're going to use table 3. Okay, table 3 is a table of cumulative area to the left of a particular given z-score. So let me bring that table here. Okay, so now we have the table here, and this table will represent the values or the areas of a particular z-score to the left of that z-score. Okay, so now how do we read this table? Look here that we have the z-score right over here on top. Okay, and since we know that the z-score has two decimals, then we're going to have to actually match the rows of the z-score with the columns. So the z-score has the z-score is located in the margins, right? In the margins right here. Column headers and row headers here. Okay, with units and tenth digits along the left side right here, right? And the hundredth digit across the top. Okay, so how are we going to read this now? If we need a z-score of 1.24, the first thing we need to do here is find 1.2. So 1.2 is this right here. So now what we need to do is go across and find the 0.04, which is the second digit, the second decimal, or the 100th digit. So this 4 actually will come right over here and make 1.24. Okay, so when now the row matches with the column cell, we have our area. Okay, we have our area. And this area right now is going to be written as the probability of z smaller or to the left of 1.24, right, because this is smaller this time here, will be equal to 0.8925. So that is the area under the standard normal curve to the left of z 1.24. Okay? Let's find now the area to the right of the z value. One thing that you have to really keep in mind here is that the distribution curve, the entire normal distribution curve, is equal to 1, and that was the first property of a normal distribution, right? Because, and this is the key factor in determining probabilities that are associated with values to the right of a z-score. So we have to really understand that, because the table here will give us values that are lie to the left of a z value, to the left of a z value. Okay, so we need to find out to the right by subtracting the left area from 1. Okay, so let's understand that. Find the area under the normal curve to the right, okay, of a z 0.32. So now we know that the mean is 0, one standard deviation is right over here, so 0.32 probably would be somewhere over here. Okay, somewhere over there. So that's going to be 0.32. Okay, so now we want the area to the right. Okay, since we can't find that right now in the table, okay, well, all we need to do is find the area to the left, because that's given in the table, and subtract that area from 1. So 1 minus this will be equal to this. Okay, so let's see now, what is the area or probability to the left of a z equals 0.32. We go to the table and we find 0.3, right? 0.3 is the the 10th digit, 0.3, and then 0.02 will have our 100th digit. Okay, so we go across, and then where we find the cell that matches the column of 0.02, we get our area. Okay, so now the probability associated with z smaller or to the left of 0.32 will be 0.6255. But the probability of z greater than 0.32, which is this area over here, okay, will be 1 minus 0.6255. Okay, and that's going to be equal to 5 4, right, 7, and then 3. So it's going to be 0.3745. So that's the correct answer. Let's move on now and find the area between any two z values. Okay? So the first is find the probability that z lies between 0.7 and 1.98. Okay, so the mean is 0 here, and the first z lies in the 0.7, so probably is right somewhere right over here, 0.7. Okay, and the other one is 1.98. So all the question is asking is to find this area in between, bound by two z-scores. So how do we find that? Intuitively we know that this area will have to do some subtraction, right? So what we're going to do here is find the find the area that corresponds to the left of z equals 1.98, right? Then find the area that corresponds to the left of z equals 0.70. Okay, there is a digit here, a second digit, 0. And what we need to do is subtract the smaller area, this, from the bigger area, and then we will have the area in the middle. And that's what we need, right? We need this area right here. So let's find that. Let's find that. Let's go to the table, right? And find all of these areas for the given z's. Okay, so let's find the probability for the area associated with z smaller than 1.98, or the area to the left of 1.98. So what we're going to do here is find 1.9, right? Find 0.08, because that 8 will come here and be 1.98. Come down here, and then where these two meet, we're going to find that area. So that probability, right, of z smaller than 1.98 is going to be 0.9762. Okay? What about probability of z smaller than 0.70? Let's do the same thing. Find 0.7, 0.00, because that's 0 will come right over here, and then we have the probability or the area of 0.7580. Okay? In this case now we're going to find the probability of z smaller than 1.98 and greater than 0.7 by subtracting 0.7580 from 0.9762. Okay, so that's going to be equal to 0.9762 minus 0.7580. So the probability for the area that is smaller will be subtracted from the larger one to find this area here in the middle. That's what we want. Okay, and that's going to be equal to 0.1357. Okay, so this probability here will be 0.1357. Okay. What about the probability that the z lies between minus 1.10 and minus 0.36. We know that when z is a negative value, it resides on the left side of the mean. Okay? So now minus 1.10 would be somewhere right over here, minus 1.110, and minus 0.36 would be somewhere over here, minus 0.36. So all we need now is this area that is bound by these two values. So how do we do this? Since table 3 gives us the cumulative area to the left, again we're going to find the area to the left of minus 1.10, find the area to the left of minus 0.36, right? And then subtract the smaller area from the larger area to find the area in the middle. Let's bring the table 3 here. So let's find the probability of z smaller than minus 1.10. So the area to the left of minus 1.10 would be minus 1.1, this right here, and 0. So that 0 comes here and becomes minus 1.10. So that goes into this cell. So that's the property, 0.1357. So that is the smaller area, the area of z to the left of z minus 1.10. What about the area to the left of z of minus 0.36? Where is that? We're going to find minus 0.3 here, and then go to the 6, and then go down here, right, and find the cell that matches the column in the row. And that cell will be 0.3594. Okay, let me make this a little bit clearer. 3594, okay? So it's that thing right here, because this 6 comes here, and that's going to be minus 0.36. So if you have a z-score that is negative value, right, that means that it's going to be on the left side of the mean, therefore in the table will probably be on the left side of the table. Okay? So now what do we need to do? We need to do the subtraction. So probability that z is between minus 1.10 and minus 0.36 will be the probability of minus 0.36, right, which is 0.3594, the probability of this bigger area minus the probability of this smaller area here, 0.1357, and that probability will be 0.2237. Okay, so the probability that z lies between these two values will be 0.2237. So that's how you find the probability of the area between two z-scores. Let's move on now to application of normal distributions. Now you saw that it's kind of easy to find the area associated with the z-score, right? So when you know the z-score, it's easy to find the area to the left or to the right of that z-score. To the left because you find it in the t-table, in the table 3, and to the right of it you subtract the area to the left from 1. But what happens when you don't have the z-score? How do you find the area? You need the z-score, so how do you find now the z value? If you recall, right, the formula for z value, or the z-score, is that z will be equal to x minus mu over standard deviation, where x is any random value, mu is population mean, and standard deviation is population, or sigma is population standard deviation, right? So x minus mu right here is nothing else but the distance of any random value from the mean, right? And standard deviation, when you divide by standard deviation, you standardize this distance and you measure it in standard deviations. So in other words, this is the formula that asks how many standard deviations the distance from the mean, the distance of any value from the mean is, right? So you standardize it. So again, the z-score, right, is equal to x minus the mean over standard deviation. Let's talk about and solve some problems now. So let's find the area now when we don't have the z-score. Let's say we have the mean and standard deviation. So the mean is mu equals 22 and standard deviation equals 2.4. Okay, so that's all we have right now. Let's find the probability that x, okay, the probability that x is in between 25.3 and 19.7. Right, so let's find that probability now. So since we don't have the z-score, we can easily find the z, right, by using the formula x minus mu over standard deviation. Now, why do we need to find the z? We need to find the z because by knowing z, we can find the area. And by knowing the area, we know the probability. So in this case, now we do have the mu, we do have standard deviation, we have the x, right? X is 19.7 and 25.3. So we have to find now two z-scores, the z-score for x 19.7 and the z-score for x 25.3, right? And once we have these two z's, we're going to find the area that these two z's border, right? So let's find the z, okay, of 25.3 first. So the z of 25.3 will be x minus mu over standard deviation, which will be x is 25.3 minus the mu is 22 over standard deviation of 2.4. Okay? And that will give us a z of 1.38. So z of 1.38 will be somewhere over here. Z of equals to 1.38. Let's find the z of 19.7. So now it's going to be x, which is 19.7, the point of that we want to find, minus the mu of 22 over standard deviation of 2.4. And that z will be equal to minus 0.96. Actually, that is minus 0.958, but we round up, and since 8 is closer to 6 than 5, then we round up at 6. So now we have two z's, z of 1.38, this one right here, and a z of minus 0.96, which will be on the left side of the mean, so it'll be somewhere over here, minus 0.96. So we need the probability of this area right over here. So what are we going to do? We already know it. We're going to find the area that bounds, or is to the left of this z, 1.38. We're going to find the area to the left of minus 0.96. And we're going to subtract this area from this bigger one to find the area in the middle. So another way of writing this, let me just undo here. So another way of writing this p of x between these two values is to write it as p of z between two values, right? Minus 0.96 and 1.38, right? So now when we go to table 3 and we find the cumulative area associated with each of these z, we're going to find that the probability of z in between these two scores will be equal to the probability of the bigger area that is associated with 1.38, and that's going to be 0.9162. You're going to find this in the table, minus the probability associated with this area, smaller area, of z equals minus 0.96, and that's going to be 0.1685, and the probability will be 0.7477. So the probability that x is in between two values, 19.7 and 25.3, when the mean is 22 and the standard deviation is 2.4, is 0.7477, or in percentage, that's going to be 74.77%. Let's do another problem like that. Okay, we have a mean of 15.2, a standard deviation of 0.9, and we need to find the probability that x is in between 14.3, okay, and 16.1. So that's going to be the probability of this x. So the first step is to find the z for 14.3. Second step is find the z for x 16.1. Then step 3 is find area for each z value that we got in step 1 and 2, right? Step 4 will be subtract larger, actually subtract smaller area from the larger area. So these are the 4 steps that you need to do in order to find, the probability or the area bound by 2 z-scores. Okay, so let's start doing it. So the first thing is to find the z-score of 16.1. That's the value right here. So that's going to be x minus mu over standard deviation. X is 16.1 minus mu is 15.2 over standard deviation 0.9, right? So the z of 16.1 will be plus 1.00, okay, because 16.1 minus 15.2 is 0.9, right? Divided by 0.9 is plus 1. What about z of 14.3? That's going to be 14.3 minus 15.2 over 0.9. That's going to be minus 0.9 over 0.9. That's going to be minus 1.00. Okay, so this is kind of intuitive for you now to understand that these two values, right, have the 0, right, fall right here, okay, between 1 standard deviation or 1z and minus 1z or 1 standard deviation below the mean, right? So we already know from the empirical rule that 68% of all cases fall between plus minus 1 standard deviation or 1z. So this is plus 1 minus 1. Is that correct to assume that this area right here will be 68%? And that is the probability? Yes, it is correct to assume that, but we are going to actually go to the table and see for ourselves, right? We're going to check if this is correct. Or if it's not correct, what is the exact probability that's associated with 1 standard deviation above and below the mean, or 1 z-score minus 1 and plus 1. So now we have the z of 16.1 will be plus 100, and the z of 14.3 will be minus 1.00. Let's go to the table and find that. So probability that's associated with the area to the left of z smaller than plus 1.00, right, is going to be 0.8413. And the probability for z associated with the area to the left of minus 1.00 will be 0.1587. Okay, so let's now subtract the smaller from the larger, right? So the probability that the z is between 1.00 and minus 1.00 will be 0.8413 minus 0.1587 is going to be 0.6826. Well, in percentage, this is going to be actually that's going to be approximately 68.26%. So does that mean that we need now to change the empirical rule of 68%? Well, we just need to refine that, right? We said in the beginning that approximately 68% will fall plus or minus 1 standard deviation. In this case, this is approximately 68%, but exactly 68.26% of a standard normal distribution will fall between 1z. Okay? So the answer now is the probability that x is between 14.3 and 16.1 is 0.6826 or 68.26%. Let's move on now and ask a real-life problem. A bank's loan officer rates applicants for credit. The ratings are normally distributed with a mean of 200, so the mean is 200, and the standard deviation is 50. It's a good habit that you write these down every time you have a problem like this. So now we have to find P60, all right, or the 60th percentile, 60% or 60th percentile. So all of these are the same. Okay. When we talk about find P60 or 60th percentile, we're talking about finding the score that is associated with these numbers here, 250 standard deviation, which separates the lower 60% from the top 40%. So if we need to, and that's another good habit, make a normal distribution curve right here, put the mean here, which is 200, right, and the standard deviation is 50, so it's 50 right here. But we need to find the 60th percentile. The 60th percentile, right, that separates the lower 60, so probably the 60th percentile would be right over here, somewhere over here, that separates this 60% here from the 40%. And this is the top 40, lower 60%. So we need to find what is the score, where is this score, is it here, or is it there, or here, or here, that separates 60% from 40%. Okay? Now the first thing we need to do here is to, since we don't have the z, right, and we need to really find the z in order to find that score, because the z equals x minus mu over standard deviation. We have mu, we have standard deviation, we don't have z, and we really need to find x, right? So we need to find z right now. With 60%, we know that P60 will be an area of 0.6000. So that falls right, it falls above the mean, somewhere over here, right? So now, since we know the probability or the area, right, we need to find the z-score from the table. So let's bring the table in and find the z-score that's associated with this percentile right here. So now, when we knew the z-score, we would actually get the 10th digit and match it with the 100th digit, and then find the probability of the area in the cell. Now all we need to do here is to find the probability of 0.6000 and then match the two digits, the header row and with the column row, right, to get the z-score, because that's what we need. We need the z. Okay, so now let's scan the table here, and since we know that this probability 0.6000 is greater than 0.5, we need to look on the right side of the area, all right, or right side of the table. So let's find here, where is 0.6000? Well, we can't really find that because there is no exact 0.6000 area. But we find that there are two values that bound this percentile, this 60th percentile. So we have now 0.5987 and 0.6026. We talked about this, and we said that we're going to find, right, the area that is closer to the area that we're looking for, and the area that's closer to the one we're looking for is this one right here, 0.5987, because this is just 0.013 away from 0.60, while this other one here is 26 units, or 0.0026. So actually 0.5987 is closer to the 0.6000. Therefore, now we go in the other way, and the other way is to just move up and move across, right? So first you move across to find the unit digit and the 10th digit. So that's going to be 0.2, and then you move up to find the 100th digit, or the second decimal, and that's going to be 5, right? It's this second here. Okay, so it's this 5 right over here. So z now is 0.25. That's great. So what we need to do here, right, is to plug in the numbers. So if z equals x minus mu over standard deviation, okay, we can change this formula so that it looks like this. X equals z times standard deviation plus mu. Now, if you don't know how this goes into that, you probably need to refresh some concepts about calculus and algebra, or maybe see a tutor, or the part of the Blackboard section. But if you don't really need to do that, you just remember that this is the formula to find the z. I'm sorry, to find the x, or the value. So let's find now what the x is, and that x will be the score. You see here in the question, the score which separates the lower 60 from the top 40. So if x will be z times standard deviation plus mu, now we know z, we know standard deviation, and we know mu. So that's going to be equal to z is 0.25 times standard deviation is 50 plus mu is 200. Okay, and the x now will be 212.5. So the score which separates the lower 60 from the upper, or the top 40, is 225. I'm sorry, 212.5. And we know that the mean is 200, so 212.5 is right here. So this separates lower 60% from top 40%. Okay, so this is the answer. So let's do the last exercise or the problem for this podcast. The weekly salaries of teachers in one state are normally distributed with a mean of $490. So the mean will be $490, and the standard deviation will be $45. Now, what is the probability that a randomly selected teacher earns more than $525 per week? So the probability is of x greater than 525. Okay, so we need to find that probability. So let's visualize this now. So we have the mean 490, right? But we need to find the probability that a randomly selected teacher earns more than $525 per week. So $525 probably is right over here. So we need this area right here, so the area to the right. Okay? So first we need to find the z-score that corresponds to this particular value, 525. Then find the area to the left, right? And subtract this area from 1. And then we're going to find the probability that the randomly selected teacher earns more than $525 per week. So step 1 is to find the z-score, right? Z-score will be equal to x minus mu over standard deviation. In this case, we know x. X is 525. Minus mu, that's 490, over standard deviation is 45, right? So the z now will be equal to 35 over 45, and that's going to be equal to 0.78. So the z-score is 0.78, right? So now we need to find the area associated to the left of this 0.78. Okay, so we go into the textbook and we find in the table that the area to the left of z, so the probability of the area to the left of z, 0.78, will be 0.7823. Okay, so this probability right here, okay, is 0.7823. But actually, the question asks, what is the probability that randomly selected teacher earns more? So we want this area here. Okay, so in this case, we need to do probability that z greater now, that's 0.78, equals to 1 minus probability of z smaller than 0.78, and that's going to be equals to 1 minus 0.7823, and that's going to be 0.2177. So the probability that the randomly selected teacher earns more than 500, so P of x greater than $525 per week would be 0.2177 or 21.77%. So that's the answer. Okay. Good luck. And let me know if you have any other questions.